Enjoysport Hypothesis Representation. Each hypothesis consists of a combination of constraints on the instance attributes. Each hypothesis will be a vector of 6 constraints specifying the values of 6 attribute values. The attributes can be sky, air temperature, humidity, wind, water, and forecast. Hypothesis is a set, and in the hypothesis set we will have a set of constraints. In our example, it is 6 constraints. Each attribute will be either question mark or a single attribute value or a null value. Question mark will indicate any value is acceptable for the attribute. It is a don't care value. Single value may be attribute values. In case of sky, it may be sunny, rainy, or cloudy. 0 or null value will indicate no value is acceptable for the attribute. Hypothesis representation. One hypothesis sample is shown. It contains 3 constraints. Those are sunny, strong, and same. These hypothesis values are taken from attributes sky, air temperature, humidity, wind, water, and forecast. The most general hypothesis is a set consisting of all question mark. The most specific hypothesis is a set consisting of all null values. That will indicate no day is a positive example. Enjoysport concept learning task requires learning the set of days for which Enjoysport is yes, describing this set by a conjunction of constraints over instant attributes. Enjoysport learning task requires that learning set need to be positive. Enjoysport concept learning task. We are studying what is the task of machine in case of Enjoysport concept learning. What is the given data? Given data is instances capital X that consist of set of all possible days, each described by the attribute values. In case of our example, the attribute names are sky, air temperature, humidity, wind, water, and forecast. In case of sky, the attribute values are sunny, cloudy, rainy. In our example, in the table, the cloudy attribute value is not shown. In case of air temperature, the values are warm and cold, and so on. The target concept is small c. In Enjoysport, the target concept is a Boolean value. Either it is a 0 or 1. It will indicate whether the person will enjoy the sport or not. Hypothesis capital H. Each hypothesis is described by a conjunction of constraints on the attributes. Hypothesis capital H is a set. This set consists of hypotheses like small h1, h2, h3, and so on. Training examples D. Positive and negative examples of the target functions are considered here. What we need to determine in case of Enjoysport concept, a hypothesis small h in capital H such that small h of x is equal to c of x. We need to find out most specific hypothesis which will satisfy the target concept, and it is applicable for all the training examples. The inductive learning hypothesis. Definition of inductive learning hypothesis is any hypothesis found to approximate the target function well over a sufficiently large set of training examples will also approximate the target function well over other unobserved examples. This indicates that if we have sufficiently large set of training examples and if a hypothesis is approximating the target function over this, the same hypothesis will approximate the target function on unobserved examples also. Inductive learning is also known as discovery learning. It is a process where the learner discovers rules by observing the examples. Concept learning as search. Concept learning can be viewed as the task of searching through a large space of hypotheses implicitly defined by the hypothesis representation. The goal of this search is to find the hypothesis that best fits the training example. Hypothesis is a set. It is represented by capital H, which is having the elements H1, H2, H3 and so on. These small H1, H2 and H3 represent a hypothesis space. In this, we need to find a hypothesis which will best fit the given training example. By selecting the hypothesis representation, the designer of the learning algorithm implicitly defines the space of all hypotheses that the program can ever represent and therefore can ever learn. If that is the specific hypothesis, it will satisfy all the training examples provided. Enjoysport hypothesis space. In Enjoysport hypothesis space, sky has 3 possible values and other 5 attributes have 2 possible values. In the table, the 3 possible values of sky is not shown. Only 2 possible values are shown. They are sky and rainy. Cloudy value is not shown. In other 5 attributes, 2 possible values are taken. For example, in air temperature, the 2 attribute values are warm and cold. In humidity, it is normal and high. In wind, it is strong and normal. In water, it is warm and cool. In forecast, it is same and change. Some of them may not be shown in the table. There are 96 distinctive instances in capital X. How we got 96? We need to take all the possible values in each attribute. In first case, that is in sky we have got 3 and in all other attributes we have got 2 values. If you multiply 3 into 2 6 times, then we will get 96. There are 5120 syntactically distinct hypotheses in capital H. How we got this value? Apart from the distinctive instances, we have got 2 more values. Those are question mark and null value. These 2 is been added for each distinctive instances. So 3 become 5 and all 2 becomes 4. When we multiply 5 into 4 6 times, then we will get 5120. Every hypothesis containing one or more zero symbols represent the empty set of instances. It classifies every instance as negative instance. We will separate this zero symbol set. So we will get 973 semantically distinct hypotheses in capital H. In case of distinctive instances, that is 3 into 2 into 2 into 2 into 2, we will add one more, that is question mark set, and the null set we will separate. That's why it is shown as 1 plus 4 into 3 into 3 into 3 into 3 into 3. That will constitute 973 semantically distinct hypotheses in capital H. Although Enjoysport has small finite hypothesis space, most learning tasks have much larger hypothesis space. In our example, we have got only 4 instances, but in actual case, there are tens of thousands examples possible. General to specific ordering of hypothesis. Many algorithms for concept learning organize the search by relying on a general to specific ordering of hypothesis. This indicates that many algorithms will organize the hypothesis space from general to specific. That is, they will iterate through hypothesis to hypothesis. It may be in the beginning H0, then again more specific H1, H2, H3 and so on. Consider 2 hypotheses, H1 and H2. If you see, H1 has got 2 constraints and H2 contains only 1 constraint. Now consider the sets of instances that are classified positive by H1 and H2. Because H2 imposes fewer constraints, it contains only 1 constraint, that is sunny, on the instance. It classifies more instances as positive. In fact, any instance classified positive by H1 will also be classified positive by H2. Means in H2 we have got sunny. In H1, sunny attribute value is also included along with strong. Hence, H2 is more general than H1, since H1 contains 2 attribute constraints and H2 contains only 1, which is general in case of H1 and H2. Hence, H2 is more general than H1. More general than relation. For any instance small x in capital X and hypothesis small h in capital H, we say small x satisfies small h if and only if h of x is equal to 1. There are two terms here. One is capital X and one is capital H. Capital X will indicate all the training samples, training sample space. Capital H will indicate hypothesis space. Hypothesis space consists of each hypothesis in the set. It may be H1, H2, H3 and so on. In case of samples, each sample is represented by small x1, x2, x3 and so on. If hypothesis of one training example is yes, then it indicates that that hypothesis will satisfy that training sample. More general than or equal to relation. Let small h1 and h2 be the two boolean valued function defined over capital X. Then small h1 is more general than or equal to h2 if and only if any instance that satisfied h2 also satisfies h1. Means the constraint present in H2 are also present in H1, then it is more general than or equal to H2. H1 is more general than H2 if and only if H1 is greater than or equal to H2 is true and H2 is not greater than equal to H1. We also say that H2 is more specific than H1.